if we can define the inverse hyperbolic trig functions, we should be able to take their derivatives. Okay, and so that's what we're going to do here. Now, there are two options for that. One is you could write sinh inverse in terms of the natural log and then take the derivative of that. Don't do it that way, okay? Because I've told you I'm not giving you any credit for having it memorized how to write sinh inverse in terms of the natural log. So if you're going to do that, you have to first do that derivation and then take the derivative. That's two problems in one, and there's a much simpler method that we've already seen. We took the derivatives of the regular trig functions using implicit differentiation. So we can do the same thing with the inverse hyperbolic trig functions. So this is actually a breath of fresh air. This is basically going to be review of something that we've done before, which is kind of strange in this section because it feels so new. Okay, so what I would say is the original function, sinh, is y equals sinh x. So that means that the inverse function, sinh inverse, and I'm just, well, I suppose we should write in the argument of x, okay, means that x is equal to sinh of y. Okay. So I'm just going to use implicit differentiation and take the derivative of both sides. Derivative of x is equal to the derivative of sinh of y, remembering that here, since the variable with respect to which I'm taking the derivative doesn't match the variable here, this is implicit differentiation, or just chain rule. Derivative of x is 1. Derivative of sinh is cosh. And then we have to multiply by the derivative of the inside part, which is just y prime. So then we solve for y prime, and we get that it's 1 over cosh of y. And just like with the regular trig, because we actually do know exactly what y is in terms of x, we ought to be able to explicitly write this in terms of x. Now I've got a cosh y here. If I had a sinh y, this would be a sinh. I wait all semester for that pun. Oh, yay. Okay, so I would like to express the denominator here in terms of sinh y so that I can replace sinh y with x. Well, lucky us, we've got an inverse hyperbolic trig identity that gives us a relationship between cosh and sinh. I know that cosh squared y minus sinh squared y is equal to 1, which means that cosh squared y is 1 plus sinh squared y. And I can take the square root of both sides. Of course, the square root of cosh squared is the absolute value of cosh of y, and that's going to be the square root of 1 plus sinh squared y. I do want to see this work if I'm asking you to derive this. But now I know something about cosh. Cosh is always positive. So the absolute value of cosh y is just cosh y. Now, I want to see that explanation. Again, that's because, and it's actually always strictly positive, so I can use a strict inequality there. Okay. I want to see that explanation because I'm not a mind reader. I can't tell the difference between a student who remembers that cosh y is positive, so that the absolute value of cosh y evaluates to just cosh y, and a student who doesn't know what to do with the absolute value sign, so just stops writing it because it makes things more complicated. Okay. So I need to see the reason that it disappears. But then we can say cosh y is just the square root of 1 plus sinh squared y. Awesome. So this becomes y prime is 1 over the square root of 1 plus, and I'm just going to emphasize that that's sinh of y quantity squared. But remember, sinh of y for this problem was x. So y prime is 1 over root 1 plus x squared. All right. Now, with these formulas, don't memorize those. I've said that we will be working with regular inverse trig often enough that you should know those formulas. When we get to the part of the class where I'm saying, here's a function, what's it the derivative of, I could give you 1 over 1 plus x squared, which is the derivative of arctan. And I could say, what's it the derivative of, and expect you to know that it's the derivative of arctan, among other things. That answer isn't unique. Okay, but I do not expect you to have these memorized. Okay, so you are not responsible for knowing the result the way you are with the regular inverse trig. However, you are responsible for being able to derive the result, very similar to what we did with the regular inverse trig. You're just using the hyperbolic identity, and then your reasoning for figuring out whether to choose the positive or the negative root really has a different meaning. With regular trig, we're looking at what quadrants are we working in. With hyperbolic trig, we're just using things like the fact that cosh is always positive. And in the next video, we'll work out the derivative of inverse hyperbolic cosh. Okay, you should be able to work out the derivatives for all 6 of the inverse hyperbolic trig functions. I'm not going to do all 6 of them in these lecture videos, simply because this really is review of what we did in the regular trig. But one issue does come up when we look at the derivative of inverse hyperbolic cosh, simply because that was one of the functions where we did actually have to restrict the domain. So we'll work through that in the next video.